So this video is going to talk about page 43, which is topic 3, quadratic and cubic equations. So this is going to be all the calculator work that goes along with the page. So if you have page 43, it has a scatter plot. I'll do an accompanying lesson, video lesson that kind of talks about what we're going to do with that scatter plot. If you look at my diagram, it says look at the scatter plot below. What type of function do you think would best fit the data? Linear, quadratic, or cubic? Explain. Well, as you can see from the lines that I've drawn, there's actually drawing lines for all three of those. There's a straight line drawn through for a linear function. There's a curve that represents a quadratic function. And then there's a curve that represents a cubic function. So all three of them can be sketched in to represent the data. Now the following table, there's a table there, lists the points that were plotted on the scatter plot again. Based on the table of values, what function do you think would best fit the data? So we've got these three possibilities: linear, quadratic, or cubic. One of them could do. So you may look at it and go, I really think that's a nice curve, that's going to be quadratic. Or you may look at it and you say, you know what, I think actually they're pretty in a straight line, so we'll use linear. Or you may say, I think it actually fits cubic. It's up to you as to what you think. There's actually a methodology where we can tell. So that's what we're going to do right now using our correlation coefficient. So here's our calculator. Now remember, way back when yesterday, it was so long ago, we are following the steps on page 56. Okay, so the first thing we're going to do is we're going to do step number 1. We're going to turn diagnostic on. This is very important because this is going to tell us our R-squared values. So following those instructions. So never mind, graph, and I'm going to clear that. I have to get a clear screen. Okay, so I go second function, and then I go 0, oops, and then x to the minus 1, and I'm going to scroll all the way down till I hit diagnostic on. Then I'm going to press enter and enter again. And when it says done, you can see there the screen says done. That tells me that my diagnostic is on, and that's important for this purposes. Okay. Then I'm going to go through the whole process of linear regression. So we're going to follow all those steps. So the next thing we're going to do is we're going to clear all the equations from y, then clear all our lists, then insert data from the chart, and then turn the stat plot on. We'll also adjust the windows and look at the scatter plot. So we're basically doing 1 through 6 on page 56. It's at 7 that we're going to have some different options. Okay, so following these in particular. So first, we're clearing all the equations from y. So I hit my y equals. I'm going to clear that, and I'm going to clear that. I don't want any of that junk in there. Okay, then I'm going to clear all my lists. So I hit stat and enter for edit. I go up to the top of list 1, hit clear and enter. Okay, scroll over, go to the top of L1, hit clear and enter. Now my lists are all clear. Okay, at this point I can start adding in my data from the table on page 43. So for my x values, I have 5, 6, 7, 8, 9, 10, 11, 12, and 13. Go over to column number, press enter, and then go over to column 2. Now I have 3, 10, 50, 66, 140, 275, 345, 514, and 731. Enter. Okay, that's my data. Now I need to make sure that my stat plot is on. So second function, y equals, that's stat plot. And right now stat plot, if I look under 1, it's off. So I hit enter and I turn it on. Okay, so now it's highlighted, it's on. And just double checking, I've got a scatter plot graph, X list is L1 and the Y list is L2. So we're good there, okay? I don't need to do anything more with that. Then I'm going to adjust the windows. So I hit zoom and I scroll down, or I don't have to scroll down, I'm just basically hitting 9 and it's gonna graph. So there's my points. So that's what I saw on the graph. Now it probably has slightly different windows than what we saw on our sheet, and we can adjust those, but it doesn't really matter for what we're doing. Okay, so what we're going to do is we're going to determine the function that fits the data best, and we're going to perform 3 regressions. So the first regression is the one we've already done. We know this one. The first regression we're going to do is a a linear regression. Okay, and I got some paper here because I'm going to write some numbers down. So to do a linear regression, I hit stat, I go over, use my arrow and go over to calc, and for a linear regression you can see it is number 4. So I hit 4, and then I want to put in my L1 and L2, so second function 1, that puts my L2, comma, second function 2. So it's L1 and L2. And then I hit enter. Now, I could write all that down for my linear regression, right? So that I'm copying this down. You know, I've got A is equal to 87.05, B is equal to negative 546.3388889. That's great because that's y is equal to ax plus b. In case it happens to be a linear regression, I'm going to want that information down. But the thing I really want to look at is the R2 value. So the R2 value here is equal to 0.8849. And I can continue, but 4 decimal places is enough. What this R2 is our correlation coefficient. Okay? So the closer the R2 value is to 1, the closer that line is to representing the line of best fit. Okay, so that's number 1. So I wrote all that down, so I have it for later. Okay, so this was my linear regression. Okay, I want to keep that. All right, now we can do a quadratic regression. So same steps. We've got all our data in, so I'm going to just clear that. I hit stat, I arrow over to calc, but if I look down one more from linear regression, I have quad regression, so it's a number 5. So quad regression, again, second function 1, comma, second function 2, and then hit enter. So my quad regression, I have, it's y is equal to ax squared plus bx plus c, right? You can see that on the screen. And my a is 13.48809524. I may not need all those decimals. B is negative 155.735714. And C is 456.276195. Okay? Now, the important number for my quad regression is my R2. My R2 is 0.99400, and there's a bunch of other dots. So, comparing that to our R2 for our linear regression, the quadratic regression is much closer to 1. So, it means that it's more likely to be a quadratic regression than a linear regression, or a quadratic function than a linear function. That is what that number is telling me. However, we're not done. There's one more regression we can do, right? So this is our quadratic regression. Now the last one we're going to do, you guessed it, where all our numbers are in there, we're going to do Same thing, stat and calc, and then if you look down below that, it's number 6 is cubic regression. So we hit 6, and again, second function 1, comma, second function 2, I'm still safe, and it's going to think, and then we're going to have cubic regression. And again, I'm going to write all this down, ax cubed plus bx squared plus cx plus d. My a is 0.797979, etc. B is negative 8.05739 ... I'm not going to need all those decimal places. C is 28.75721 ... and D is negative 40.70562, etc. But the most important number is our R square, and it is 0.99577 ... right? So, looking at those, when I compare all three of those R values, so if I look at all three of them, the one for linear, the one for quadratic, and then the one for R squared, the cubic is the closest to 1. So what that tells me is, is that writing all those down, and I've sorted them out there, I think I did a little rounding. No, that's about right. Okay. Cubic R squared is closer to 1. So that means that based on that correlation coefficient, the type of function that best fits the data is cubic. Okay. So we use that R value to help us sort out which function to use. Okay. So that's page 43. And then we're going to talk about the next page. Okay?